Most welcome. I just want to talk about some few things, and today I want us to discuss about the greater response to stress. How does the body respond to stress? How does the body do it out that you can overcome the stress? Basically, the body inside, there are a lot of causes of stress. And first of all, stress can be caused by many things. We have three major forms of stress. You have stress which is physical, you have stress which is emotional, you have stress which is biological. And emotional stress, I will talk about things like fear, things like anger, things like fatigue, yeah. Those things are too emotional. Now we have things which are stress, the former stress, which is physical. Physical stress, I can talk about pain, I can talk about low temperatures, higher temperatures, I can talk about things like that. That is physical. And third is biological. Biological stress can be in terms of hypoxia, terms of hypoglycemia, terms of hypotension, hypovolemia. Those ones are all forms of stress. But how does the body respond to stress? If you are in stress, why receive stress? Why knows that you are now in stress? How is the body informed about stress? First and foremost, stress information is received by higher centers from the cerebral cortex to down to the brainstem. Yeah, that is how large stress will activate the brain. And basically, in stress, those centers I've talked about from cerebral cortex to the brainstem will be including even the limbic system and the reticular activating system in response to stress. And for what I'm going to talk about today, if those are the systems which respond to stress, those are the systems which receive the stress. Now let's talk about the two pathways. There are majorly two pathways which are responsible for that response. I'm talking about integrated response to stress. Body integrated response to stress. One, we shall have a pathway which will cause release of cortisol. And two, we shall have a pathway which will cause release of catecholamines. The pathway which causes release of cortisol is called, it is an axis. Yes, an axis from hypothalamus through the pituitary, through the adrenal cortex, and that layer is called the fasciculata. Zona fasciculata is the one which releases cortisol. So that one, it will release cortisol into blood, and cortisol will respond to stress. And two, we have a pathway which will involve the nervous system. So adrenergic neurons in the hypothalamus will be activated. When they are activated, the sympathetic system now is activated, and that is majorly posterior nucleus of the hypothalamus. Yes. On activation of the sympathetic system, recently we said that we have adrenomedulla, which receives splanchnic nerves from T5 to around T9. Those ones, when they send sympathetic signals to the adrenomedulla, chromatin cells will be forced to release epinephrine. You get? That epinephrine enters blood, and it is just one catecholamine. Now the second catecholamine comes from sympathetic ganglia. The postganglionic neuron of the sympathetic nervous system will release norepinephrine into blood. And the norepinephrine, in addition to catecholamine, it is finding their cortisol in blood. All these three things will cause an integrated response to stress. So the pathway for release of catecholamine will involve the hypothalamus and the sympathetic system and the adrenomedulla. So it is sympathoadrenomedullary system. You get? Yeah. So now let's talk about what happens if you have now cortisol, we have catecholamines in blood. First and foremost, I will talk about the glucose. What happens to glucose? These things will ensure that we have glucose in blood. The cortisol and the catecholamines will prevent utilizing of glucose by peripheral tissues, and they concentrate glucose to be used by tissues which are around the center of the body. And to talk more about glucose, The catecholamines cause glucogenolysis. You get? Glycogenolysis. They will cause breakdown of glycogen in the liver. Whereas the cortisol will make sure we have amino acids in the blood. These amino acids are used for gluconeogenesis in the liver. So, as cortisol is supplying amino acids, it also has an effect. It supplies amino acids for gluconeogenesis. The catecholamines are causing glycogenolysis. So, the glycogen in the liver will be broken down. That is one. And two, basically, we shall talk about free fatty acids. Yes? The cortisol has a lipolytic effect. It will cause lipolysis of the tags in adipose tissue. So these fatty acids are provided, and the epinephrine will ensure that they reach the organs which are requiring fatty acids for action. For example, the heart. It will make sure the fatty acids reach the heart. It will also make sure that the fatty acids reach the liver. Fatty acids reach some muscles. Yeah. That is it. And the third point I can talk about in integrated response to stress. Yes, relax. We are still continuing. In the integrated response to stress, what happens? Let me get a mark here. We can talk about arousal. Yes, the reticular activating system will be activated. And in activation, it is making you be alert. It is making you be attentive. You get? So it increases the attention. You increase in attention, and that behavior is important defensive-wise, because you have to be informed about where you're going. You are in the flight or fright response mode, so you need to be alert. And four, we shall talk about cardiovascular effects. Both catecholamines and cortisol have an effect of raising cardiac output and contractility of the heart, cardiac output and heart rate. Yes, they increase those two. They raise blood pressure so that they raise cardiac output so that services can be taken to organs which require them at a faster rate. Yeah. The fifth point I can talk about inhibition of activities which are not useful during stress. For example, during that stress when you're running away from danger, as you're running away from danger, there is an input of cortical. In fact, I did explain this, but look at this. That when you are in stress, the hypothalamus has ADH neurons. This will be activated. Major stress will activate ADH neurons and the activate nucleus to release corticotrophin releasing hormone. You get? So the corticotrophin releasing hormone is the one responsible for causing release of ACTH, which goes to adenomedulla and release cortisol. You get? So ADH is also activated. Those two, CRH and the ADH neurons, will activate release of adrenocorticotropic hormone, which causes release of cortisol. Now the CRH, corticotropin releasing hormone, from the hypothalamus, it has an input within the hypothalamus. That is a short loop, an ultra short loop. And that loop, as it puts signals in the hypothalamus, it is released. It will also inhibit release of growth hormone, such that you don't need to grow at times of stress. It will inhibit the release of gonadotropins, and so sexual behavior will be lost. Yes, those two are inhibited because they are not important in terms of stress. A sixth point I can talk about interaction with the immune system. These hormones ensure that there is a balance between the cytokines released. There should be a balance between cytokines, like the immune system usually produces some chemicals which are highly toxic to the body, and also its products are not usually good. It has those things which are damaging to the body. But they ensure these hormones within the integrated response to stress. They ensure that the immune system, there's a balance between cytokines which are important to reduce threatening stimuli, and the cytokines which there is a balance to avoid damage of the tissues in terms of stress. And the sixth point I can talk about, yeah, that is basically what happens. Yeah, thank you.